Welcome back to Chapter 14 of America's Boating Club Sail Course. In this chapter, we will be covering sailing upwind. In this case, we're going to illustrate the difference between starboard tack and port tack. The tack you're on is which direction the wind crosses the boat first. So here we have our wind coming from the top of the page. So the wind crossing this one is going to cross the starboard side of the boat first, therefore they're on starboard tack. Starboard tack, another way of looking at it, is the side that is opposite the side that the main is on. So in this case, the main is on the port side of the boat, so that shows we're on starboard tack. Down here, the boat is on port tack, so the wind is coming over the port side of the boat first, so that says it's on port tack. And our main is also over the starboard side, which is the opposite side of the boat. So the main is on the opposite side. When it's on starboard, you're on port tack. Sailing close hauled is when you trim the sails in really tight and you're steering as close to the wind as possible. This is usually within 45 degrees of the true wind. When a boat is sailing too close to the wind, to the apparent wind, it's called pinching. And so this boat is sailing too close to the wind. As I mentioned in the previous chapter, you can pinch a little bit. When the boat is going fast, you can pinch up a little bit, but then as soon as the boat slows down, then you need to return to the normal efficient course. So a boat sailing close hauled is pointed close to the wind, approximately 45 degrees to the true wind, and the sails are trimmed in really tight. What this slide is trying to show us is that if the wind is consistently blowing in one direction, it doesn't matter whether you sail on port tack or starboard tack, it's the same distance that you have to go. So here we have a boat that's going close hauled on port tack. He's going to go 7/10 of a mile this direction, tack over, and it's 7/10 of a mile that direction. It's the same distance as a boat on starboard tack. It would go 7/10 of a mile and 7/10, 1.4 miles. It doesn't matter which direction on either tack will get you the same way. When we were dealing with vector diagrams, we talked a little bit about what the effect of a header is. And a header is when the wind moves ahead, moves forward on our boat. So here we have the wind coming down. We're sailing up close hauled. The wind shifts a little bit, so it moves forward. And so now we have to change, in order to keep our sails flowing well, we have to change course to accommodate the header. As we said, if the wind didn't change directions, it wouldn't matter whether we were on port or starboard when we were going upwind, because we'd be going the same direction, the same distance. However, if the wind changes direction, that also changes the distance that we have to sail to get to our upwind mark. In this example, we're going to see how the distance between the two boats changed because of the wind shift. We have the original wind shift coming straight down the course, and the wind shifts over to our new direction. If these two boats were going the same direction until the wind shifted, the red boat, after the wind shifted, he would be going in this direction because that's a close haul direction. But since he got a header, he tacked on the header and then made his direction up to the mark. Boat B did not, he went over in this direction. He got lifted. He didn't get a header. He was on the opposite tack. When you're on it, he got lifted up here, and then he had to take another tack, which sailed a longer distance. Most of our conditions sailing around here in Clinton Lake and other places, we're sailing in this oscillating direction, where the wind shifts from this direction over here for a little bit, and then it shifts back, and then it shifts back and forth as you go up the race course. So in oscillating wind conditions, what we want to do is always tack on a header. So when the wind shifts, tack and go that way. When the wind shifts back, then you consolidate your differences. Just like any rule of thumb, there's always an exception. So when you're in oscillating wind, you're going to always tack on a header. However, if the wind is persistently changing, like when we're getting a frontal passage or a sea breeze, that means we want to sail to the new wind first and then on a header, if necessary, sail to the new wind on a header and then tack, and you'll get lifted to the mark as you go. Another way of looking at this sort of thing is that we consider the course to be a set of ladder rungs that are perpendicular to the wind. Here's our wind coming down this direction, and each one of these lines across here is a ladder rung. Boats on the same ladder rung are tied, no matter how far apart they are. Now let's look at the impact of a wind shift. On this one, we had the wind going straight down this triangle. It shifted over to our left, and so now we have a new triangle, new ladder rungs that are now perpendicular to the new wind. So when this wind shifted, the red boat moved up to a higher ladder rung, and just by virtue of the wind change, it actually went ahead of the green boat. This is why it is so important to pay attention to wind shifts and then tack on the headers when they occur. On bigger boats, we've got a lot of adjustments we can make to the jib to make it change its shape. We're looking to almost have the leech, that's the back end of the sail, almost touching the spreader, and then have that gap, the slot, the gap between the main and the jib to increase from head to foot. If we sail too high, as in pinching, the luff is going to start trembling and the inside telltale will start to flutter. That'll tell us that we need to steer down just a little bit. But we also can look at those telltales, and we'll have multiple on the front of the jib, one high, one in the middle, and one down low. And we'll look at those telltales and see if they're breaking at the same time. So the inside one starts fluttering up high or down low. If they're all start fluttering at the same time, that means we've got it trimmed pretty well. If the telltales are not changing at the same time, then we can add twists to the sail to to adjust so that the telltales do trim out at the same time. Turning blocks on the deck allow us to change the jib leech twist. If the jib breaks near the foot, we're going to move that block back. If the jib breaks first near the head, we're going to move the block forward. The way I look at it is we're going to move the car to consider which the direction the force is being applied. The farther forward the car is, the more downward force will apply. The farther back, the more we'll stretch the foot of the sail more. So we can add twist to the jib by moving the car forward. This will provide more downward force on the leech. To increase twist in the jib, we're going to move the car back, which will then pull the foot tighter and make the sail flatter. On my Thistle, the jib lead position doesn't move much. It's pretty well set. However, on my Capri, we move the car around a lot based upon the sail choice as well as the wind conditions. And sometimes we have the jib car position on the deck actually marked from a previous setting, so when that was fast, then we can quickly move that to that position for that day of sailing. When we adjust the outhaul, we're going to pull it on pretty tight on a laser. I typically stretch that bottom. The outhaul stretches the bottom of the foot of the sail and pulls the draft in, reduces the draft. And you'll see these wrinkles in the bottom of the sail. On a laser especially, when we're taking off before we go sailing, I usually put the wrinkles in there. And then when we get out in the breeze, the wrinkles go away. In this picture here, you can sort of see that wrinkle in the main. They've let the sail outhaul off just a little bit going downwind so that it gets a little more pressure or a little more shape, let's call it, a little more power in the sail. When we tighten the outhaul, that reduces the draft, which reduces the power in the lower portion of the sail. The Cunningham on a boat controls our luff tension. It pulls down on the sail through a grommet, and it removes these diagonal wrinkles out of it. If you look at the sail over here, you can sort of just see those little diagonal wrinkles. The thing we're trying to achieve here is to get the front of the sail to match the bend of the mast. And we use the Cunningham to pull that cloth in to make it match up just perfectly. And so you'll get a nice little, the mast bend wrinkles will be coming across here back to the window. We can use the Cunningham in heavy wind to tighten and flatten the sail and reduce the power. It pulls the draft in. It reduces the draft when you pull the Cunningham on. In light wind, we're going to release the Cunningham. That increases the draft and adds more power to give the boat forward motion. Now let's look at how we trim the main for the various positions. We're going to go upwind, so we're going to have the main sheet pulled in real tight, and we're going to have a nice even slot that increases from the slot between the jib and the main. It's going to get wider as it gets closer to the bottom. Normally, we would have the crew sit on the high side of the boat to offset the force of the sail. And we're also going to try and match the sail twist, the mainsail twist, to the wind at the various heights. You remember that the higher up the mast you go, the wind speed increases. And so then we want the top part to be trimmed for a little faster breeze. So we'll set our twist with the outhaul and not outhaul, with the boom vang. And the main sheet is really how we set the twist in the main. The more you pull down on it, the less twist you have in the sail. In heavy breeze, when the crew can't hold the boat flat anymore, we're going to ease the traveler so that the boom goes down and spills some of the wind, and we're going to trim the outhaul and Cunningham hard to make the sail as flat as possible. In light wind, we're going to ease the slot and try and increase our twist to give us more power in the sail. Sometimes we can even bring the boom up closer, up to windward of the center line in very, very light conditions, if the boat has that kind of an adjustment. In this picture, it's a case where we've got the sail pulled down as tight as we can. That's called blading the sail out. And what it's trying to do is really to reduce the power in the sail. I must have thought it was pretty windy that day, and so I was trying to flatten the sail as much as possible. So if you look at the wrinkles coming out of each of the corners, that means I've got, it's pulled in really, really tight. But looking at the picture, it looks like I may have over trimmed it just a little bit. I must not have been wanting to work that hard that day. Here's a slide that looks at the various points of sail. Now we've got our close haul. The blue boat is our close haul boat that's going as tight as the wind we can upwind. It's, the sails are pulled in tight and we're running at about 45 degrees to the true wind. Everything between the close hauled and then we've got the boat that's going straight downwind, that's on a run. Everything that's between those two is our reaching area. And on a reach, we're going to trim our sails a little fuller to get more power. So we're going to ease our luff tension on the jib and the main. We're going to also probably let the main outhaul off just a little bit and try and keep the sails trimmed so that they're flowing back, just like we would going on an upwind. We'll trim the sails so that the telltales on the luff are flowing smoothly and so the wind is staying attached to the sail. Now the twist, when you reach off the wind, upwind, the twist is controlled primarily by the main sheet because it pulls down on the boom, and that's what controls that upper part of the leech of the sail. As we go off the wind, as soon as the corner of the boom gets past the corner of the stern, now the main sheet doesn't do any good, control on that, and we have to use the boom vang to control that twist. And so we can, by putting it on tighter, we can ease or expand the amount of twist that's going on in the sail. The other thing I'd like us to look at here is our angle of attack on these sails. So as we go from a close haul, here's our angle of attack. It's going to be coming right at this angle. And the angle of attack on a close reach is about the same as on a beam reach, which is about the same on a broad reach. So as we go down, the angle of attack stays about the same. It's just the heading of our boat is what's changing as we go there. Coming about or tacking is when we change course, turning the boat through the eye of the wind. So our bow is going to turn into the wind and then change onto the other tack. This is going through the no-go zone. My commands for tacking, when I do it, to keep the crew and everybody on sync, I will actually count down, that's the motion. On 1, we're going to start the turn, push the rudder away, and we're going to start our turn. When we're going head to wind, I'll say 2. And then when we're on our next course at full speed, we'll say 3. And what's going to happen here is when I count 1, the crew is then going to start getting ready to tack. When we're going 2, they're going to be starting to switch sides over to the new high side. On 3, we're going to be on the high side, hiking position with the sails trimmed in and the boat going full speed. On big boats, what you might hear is the commands at this point, ready about, and then the crew responds, ready. Buddy Malgis and David Dallin, Buddy Malgis just expects the crew to always be paying attention for the conditions and anticipate the tack. Dave Dallenbaugh, my other hero, assumes that the crew is ready unless they are told otherwise. So, in the middle. At this point, then, the skipper says, responds helmsily. That means he's turning the tiller. Or in my boat, we'll say, okay, we're tacking. We might center the traveler before the tack so that we've got our main is in center position. We don't have to adjust the main much. We might ease it just a little bit to give us some power as we come out of the turn up here. As we tack here, the jib sheets are going to switch. On this side, the jib sheet is tight. As we go through the middle here, we're going to switch over and pull the jib sheet in on the new downwind side. We need to have enough momentum to carry us through the turn. So at this point, we don't have any power. We're just using our momentum to carry us through. If we don't make it through the tack, we can always backwind the jib to help pull it around. If we get into irons, we can use the techniques of backing the boat up so that we can try and tack it again. Boats that have trouble tacking are full keel boats and catamarans because they don't have a pivot point to really turn on. They're very, the full keel boats has got a lot of underwater surface that helps it stay on its heading, and it makes it a little harder to tack. And catamarans don't have that much. There's not that much momentum mass to push them around the turn. The other thing to consider when we're tacking, when the winds are steady, the best way to make our way upwind, the fastest upwind, is to tack as infrequently as we can, because essentially we lose, every time we tack, we lose about a boat length in distance traveled. And so that's not, so when we're trying to make distance, that's not to our advantage. Let's look at our vocabulary for this chapter. Close hauled is when we're sailing as close to the wind as we can. Coming about is we change course for the bow to point through the eye of the wind, head to wind, and then head off on the other tack. Our Cunningham is a running rigging adjustment that we can use to adjust the luff tension without using the halyard or moving the boom. This completes our section on sailing upwind. Our next section will be on sailing downwind.